Okay, so our company is Hdro Corp, and our slogan is solving your environmental problems with hydroelectric power. You want to talk about the idea?
Alright, the idea is we're thinking of ways to like make stuff cleaner, like things that use like a high amounts of energy. And we realized that cruise ships use a lot of energy, so we came up with an idea to put a hydroelectric turbine on the bottom of a cruise ship, so while it's going, it can power the onboard electronics.
Wow.
Like the turbine would go like down here, and it would like spin when the boat's moving, so it would power the generator inside of it that would power the onboard electronics.
You need to turn off the ink layer to go on to the next thing.
Are you making a screencast-o-matic right now?
So the average cruise ship is about it has about 50,000 horsepower, which is about 37 megawatt average, and our generators are even better than this. They would be placed inside the hull here, and there would be a central generator system that would store all the energy, and it could again inside here, and it would be able to produce somewhere around 54 megawatts of energy.
Okay, go back to the previous slide.
Okay.
You say there that the cruise ship, this is right now. It could travel an average of 24 to 27?
That's what the average cruise ship travels.
Okay, so with this innovation, it could still maintain that speed?
We haven't specifically looked at the speeds yet, but based on what we've seen from other sources of energy that use water power, that's what they're getting per generator. So if we only put one generator in and multiple turbines, it should work that way.
Okay, go back to your diagram, your drawing. Okay, Rodrigo, explain that drawing for us.
So this drawing, this shows the hull of the boat, and basically this is the bottom part of the water.
Use the smart pens. Go ahead.
So this right here is the water, and the water, as the boat was moving forward in this direction, the water will move in through water intakes, spin the turbine, which will power the generator to create electricity.
Okay.
Spin the turbine, power the generator, electricity.
Okay.
And we can put one or either a big one or small little ones, depending on how much electricity we would need.
Could you control the angle, the direction that these turbines are with respect to the water? Because won't you get it spinning faster depending on how the current is moving in the water?
I mean, it's based. Cruise ships usually they move forward more than like sideways or anything. So we designed the product to as it moves forward, the water will be moving against the hull. So the currents wouldn't affect it that much because the boat's faster than the current. So
Okay,
the water will be primarily
this
moving.
lateral movement is inconsequential.
Yes. Since the cruise ship is moving forward, the only water coming in will be from the front.
My only concern so far is it's incredible to think that these turbines could generate enough electricity to power a huge cruise ship. I mean, what are your thoughts on that?
Alright, well we researched and it came up, I think it was like 27, like the average megawatts for
Oh yeah, it
30
was 37.
37 is the average megawatts produced by like the onboard stuff from the cruise ship.
Right.
And the type of generator we would be using can produce an average of 54 megawatts, so it'd be enough to power the entire cruise ship.
And what are the sizes of these turbines that you're talking about?
The sizes specifically, we haven't decided what's the best size that's most productive and efficient, but we're thinking of putting multiple different ones in like different places within the hull so that you'll be able to get the maximum amount of energy out of the movement of the ship.
How would you do that though?
They would be, we'd have to do more research, but they'd be placed in like different parts that were the most efficient based on our research of where the
Right. I understand that certain parts would give you a better gain
Right.
in output. I was just wondering where those parts are when you consider the layout of the underside of a cruise ship.
Where the location will be?
Yeah, where would you put these turbines on the bottom of the cruise ship in order to maximize the energy output?
Yeah, they will certainly take more space, but throughout the lower deck of the cruise ships, that's where they will be.
Well, yeah, obviously, but where? I mean, would you put it towards the front, towards the middle,
Yeah,
on the edges? You know what I
I
mean?
think it would be more along the edges for purposes because you get a stronger power from the water because it wouldn't be dulled by the bottom of the ship.
Okay.
And this is just like a simple model of what the turbine would look like with the curved like fins coming off of it, so it could get more water and get pushed faster as the water hits it.
Yeah, interesting shape. The ends there of the fans, right?
Yeah.
Of the blades.
Right, and we're still not sure how many blades we're gonna want. Like we have to research to see how many would have maximum output of speed from the water hitting it.
What about the material? What would this be? Because you're dealing with salt water, right?
yes.
Right.
So what material are you looking at?
Well, we're looking at like the same kind of material the boat might be made out of, but we have to first see if it's strong enough, because it has to be strong enough so it won't break, because it's gonna be very hard to maintain it because you can't just pull the boat out of the water like other boats.
Right. And remember, you got to take into consideration the corrosive nature of sodium chloride, right?
Yeah.
Things rust very quickly. I'm talking within a matter of hours.
Yeah.
Speaking from experience when I had my jet ski. Okay. I mean, even the ball bearings, even something as small as the ball bearings on the wheels of the trailer, that carries the jet ski. If you don't use marine grease to lubricate the ball bearings, you'll be transporting the jet ski on the highway. All of a sudden, the jet ski will be, riding on its own on the highway, and you'll be pulling nothing.
Mr. Rowe, could I say something?
Yeah, go ahead.
You also gotta watch out for when it's sitting still, because inside the salt water gets in there, it'll rust it shut and it'll stop working. Like it won't spin.
We were thinking
That's
about
not
a
gonna be-
retractable feature of the turbine so that they wouldn't be resting in the water like when the ship's at dock, because there's no purpose for that. I mean, it could be able to catch current and store some energy, but it's better that they're not in the water for the reasons you're saying. So we were thinking about a retractable feature.
Right.
So the dam we were basing it off of, the energy is the Itaipu Dam in Japan. You want to talk about
Brazil.
that? Oh, Brazil. Sorry.
It's in the border of Brazil and Paraguay, and
It's somewhere on Earth, basically.
Yeah.
so yeah, we base on the generators and how much electricity the Itaipu Dam produces per generator, and that's where we got most of our research done.
Okay.
And
So yeah, again, our energy based on what we've looked at from everything based on the ship and the Itaipu Dam, we'll be able to produce somewhere around 54 megawatts of power, which could power basically the whole ship. So it would be getting back power that it used from the fuel to move, and it would be able to power everything on the ship electrically.
Okay.
It's electric.
Alright, and pretty much the purpose is using like turbines to get the energy back from the energy being produced by the engines of the ship, so you can save fuel and you wouldn't have to use so much electricity and fuel to power the entire cruise ship.
Right, so it's not going to be used, this innovation is not going to be used to replace the main power plant of the ship.
Right.
Right.
It's
Because-
only going to complement it.
You have to come up with so much more, like to get an electric engine powerful enough to power the entire cruise ship and move it through the waves.
Right.
So we just decided to use it to power the onboard electronics.
Okay.
And then, as it says here, we're starting with cruise ships because we have to start with a particular model to work with, but it could be used on many other types of large boats, so that you'd be able to get back energy produced from the movement.
Yeah. Depending on how it works on cruise ships, we can even consider it, the Navy, or consider using their boats to power all of their electronic stuff, which is a lot. So.
Okay. Questions from the audience?
Can I think of some really quick ones? 'Cause I'm interested.
Yeah.
I just gotta give it some thought.
Any comments?
How big are these like turbines gonna be?
Again, we haven't decided the most efficient size, but it's. Do you have any?
It's gonna be like, depending on the size of the ship that we're gonna put it on, that's gonna be a big factor, and we have to consider so much more, like how much would be able to get it spinning faster, and what would get more energy output.
Will they
from it.
create like drag on the boat?
Oh, good question.
When we thought about that, it would actually create less drag than the bottom of the hull itself, because there's less touching the water at a time than the actual hole that the slit would be cut through.
Can I ask a question that, I mean, a lot of people have presented turbines in the water, and a common question that has come up, and I'd like to present it now, but it's probably not as big of an issue with cruise ships, but what about safety? At one point or another, I guess the question is, what happens if marine life, or even human life, right, were to get too close to an area that is being, that these turbines are working in?
Free sushi.
I mean, can you address that?
Well, it's as you said, it's probably not that big of an issue with the cruise ship, because they have so much safety around. Like no humans will be swimming by the turbine.
Yeah.
But the worst that could possibly happen would they get pulled up with the turbine, and then they're just inside the ship, and it's not like there's any stuff that's gonna crush them, because
Or they
it's
get
simply
chopped up
just
at the
spinning.
prop?
Yeah.
I mean,
Well, they'll
you're
go-
right.
We're not
Well, that's
doing
not
anything
an
to
issue
propel
of
it.
Someone,
ours.
if
That's
someone
not
falls
what
under
we're
a cruise
doing.
ship, you're gonna get cut up by the propeller anyway. So it doesn't
Right.
So
matter.
yeah, we're not
Or
really
the
adding
So the
massive
anything.
turbine's
amount
not
of
making it any worse.
pressure, it's gonna tear you to shreds.
Yeah. Animal
Okay, I mean,
there's fire
the
up
reason
so many-
I included this question was because in the other presentations that I've heard these past few days, with water and turbines, that question has been the most, most common one. Okay, what are you going to do with this, now that you have roughly an idea? What's the next step, folks, for you guys?
The next step would be to try to make a prototype and test it, or see how much electricity you can really make with a desired size of the generator and the turbine,
Okay,
and then based off the results of that, see the best place to place it on the cruise ship, or the size of it and everything to produce the most amount of electricity.
okay, so you're gonna have to start consulting, your physics teachers and your engineering teachers for the next step?
Yeah.
Okay. Questions, comments?
I thought it was
Yes, comments?
I mean, back to that question that you asked, maybe like when they go into an area where they know there's gonna be a lot of marine life, if they add that retractable feature, you can just pull it up for however how long you're going through that.
Good point.
Really
Very good point.
a sled that would come right out. But another question, what about the boat's ride? Like, it's probably, if it goes in the front, it's going to bring the bow down. And it'll be uncomfortable for the passengers because the waves will affect the whole ship.
Yeah, but the thing is, the turbine could be placed like on the ship, but we can always put the generator somewhere, because it can travel like a certain amount of distance before it actually needs to hit the generator to generate the electricity, so we can balance out the boat by putting the generators in certain areas.
and raise your head, right?
Or you can just add weights.
Yeah,
Right. Yeah.
if it was necessary.
I have,
Don't cruise ships have dampening devices anyway?
They have
To try to minimize,
the trim top, like trim tops, whatever.
yeah,
Yeah, they
Well,
have
the thing is,
giant
the
wings
cruise ships,
that-
dragon wings?
They're
like
too-
wings that fold out so that when it's in rough seas, it stays stable.
Right.
The thing about cruise ships though, like, they don't go that fast, they don't make that big of an effect, because not that much water is keeping the boat like that. Like if it's a small boat and they're going that fast, it make a big difference, but.
Yes.
Would the rotation of the turbine start by itself, or
Good
because
question.
It would start with the movement of the boat.
Right. Because the reason it's rotating is because the water's hitting it and pushing it to
So-
rotate.
Will this power be stored or will it just be continuing like generation? And used as its generator?
It can be stored as chemical energy.
So when it's stored, like you can have power at like, when you're not moving, you're just.
Right. So when we retract it, you'll still have stored power, and you can always, if necessary, like if it runs out for some reason, you can still revert back to the engine that's on board.
Question.
Alright, what happens if it breaks down in the middle of sea? How are you gonna maintain it, and how is that gonna, when you sell power on the ship, if it's not working in the middle of sea?
Okay, good question.
If it's not working, the original ways of the cruise ship getting electricity from the motor and the fuel burning would still.
Yeah, this is like a hybrid device.
Right.
What
It
happens
could
if,
be like on and off.
Yeah.
When it retracts, if it runs out of electricity, you can still use the motor to.
what happens if there's a problem with the, non-gas component of a hybrid vehicle? You just pull into the
Switch
gas
back.
station and switch
Back.
Exactly.
to the gas tank, right? Yes.
Well, usually the engines will produce like all the electricity
Right.
the ship needs, but I don't think you guys realize how much drag these
Yeah,
these
dude.
turbines will actually produce. And to compensate for that, you have to speed up the ship. So, is it more, add more torque to the ship using more fuel and stuff? So is it just more efficient to have the engine just powering the turbine straight, or to compensate for the drag?
That's an outstanding question.
That's what I
And
asked.
I don't think,
That's what I asked when I first heard you guys think.
I don't think that can be answered at this point. I think you guys need to do some
Right,
research.
Right.
we have to
We're
figure
gonna
out-
have to research it.
Well, I think you
I'm
guys-
so glad I'm recording this, because I'm gonna post this on the
I think-
portal, and I want you guys to listen very carefully to the
I think you guys
the
should have,
questions and
multiple
comments.
solid
747
turbines.
jets
That
already
won't
use
deep in
this.
the water.
Excuse me, one person at a time. Go ahead.
It's passenger jets already use it, so if the power goes out, a prop will come out, and it can power the props and stuff.
Right.
But it does create a lot of drag, and it could slow down the plane a lot. So this could be used to get some information.
Yeah. This is something that you guys are gonna have to go back to your physics teacher and do some research on the internet. And if your intention is to go on to the next step, you need to have that addressed, okay? Because I'm pretty sure the advisors at Conrad's are gonna ask you the same thing. Yes?
Talking about the drag, don't you think that the rotating energy, excess energy, instead of creating that drag, you could use the excess energy of the actual rotating axis that's propelling the boat? Couldn't you use the extra energy that you're gonna have to be using to destroy that drag or overcome the drag that you're slowing down the boat? Make that energy directly to the generator instead of having to wait for it to go through these turbines because it's going to be less efficient? Or do you think it's going to be equally as efficient?
I don't understand your question.
Bro,
Is it better to just
Have a generator directly inside the motor instead of having it outside the boat. Because
Do
either
you
way,
want, do you wanna draw up there what you're talking about?
That's what I asked.
yeah,
So
it's
like,
like they see
the spin of the propeller
I have
would
another
make
question.
Yeah, like the spinner's propeller is already a rotating motion. You already have it, and by putting a turbine outside the plane, the drag that you're going to be creating,
The plane?
outside the boat or whatever, the drag that you're going to be creating or the resistance you're going to be creating is going to be the same amount of energy that you're losing from your motor. So why not just put that generator directly on the motor so it's more efficient?
They do already.
That's what I was gonna say. You should just hook it up to the props instead of
Yeah.
They already do that.
just let the props create the energy because it's just the same thing as the turbine, but it's already there.
Okay,
okay,
Alright, guys.
consideration.
then we'll take that under advisement, okay? Very, very good presentation, guys.